So looking at problem number 13, know that I will put the formulas on the board. I will not tell you how to use them, but I will put these formulas on the board. Okay, I choose to use this all the time. Anytime they talk about continuously compounding, that's when I replace the ends with 9, 9, 9, 9, 4 nines. But you can also use the other formula if that's what you prefer. And I would have to look it up really quick, but I believe it was something like this. Okay, I may have forgot an A in front. I just choose to memorize one, and then I replace the N. This is used for continuously compounding. Let's take a look at what we have right now in number 13. The sum of $2,500 is invested. So I know right now this is $2,500. I've already taken care of this value. It's invested at an annual interest rate. So I already know the rate. I just have to turn it into a decimal, and it's compounded monthly. The N represents how many times does it occur within a year. There's 12 months in a year. I'll replace both ends with 12 and ask us to find the final amount after 7 years. You do need to be able to set up an equation that I can see. So A equals 2,500, 1 plus, and I'm going to move the decimal 2 places to the right, 0.0425 over 12 raised to the 12 times 7. I'm going to do this portion first on the calculator, and then I'll take it times 2,500. So let me move this up so you guys can see, and I'll move this down so it doesn't get in the way. All right, so I have 1 plus 0.0425 divided by 12. I get an answer, and then I raise it to the 12 times 7, and I'm going to take that value times 2,500. And so if we're going to round here to the nearest cents, we have $3,364.45. Let's take a look right now at number 14. At this problem, we are going to determine the amount of money that should be invested. So how much money should we invest? That means right here, what should this amount be? We're given a rate. We need to turn that back into a decimal. It's compounded continuously. Some of you will prefer to use this formula. That's fine. We want to produce a final balance of 30,000. So our final amount is going to be 30,000. So I do need to see how you're setting this up. I have 30,000 here. 30,000 equals, I don't know that initial amount. I know the rate is 0.07 when I turn it into a decimal. It's compounded continuously. So I'm going to put 999 4 times, and then up here is going to be the number of times it's compounded in a year times how many years. So I'm going to take the number of years is 12 times 0.999. Now, I still need to show my work. Hold on, I'm going to sneeze here. I'm going to get a value here on the calculator, and I don't want to round that, so I'm just going to write number sign on my paper. And I know when I divide by number sign, then I will be able to, this should have been a P, sorry. Then I know I'll be able to isolate the P, and I can get the exact principal that should initially be invested in order to end up with a final amount of 30,000 based on this criteria after 12 years. So I'm grabbing my calculator right now. I'm starting with 1 plus 0.07 divided by 9999. I'm going to raise it to the 9999 times 12. So that's like my number sign. And I don't want to round it, because if I round it now and then I round it at the very end, the more times you round it, the more inaccurate your final answer is. So I need to take 30,000 divided by this exact answer. So I'm typing in 30,000. And now to copy and paste this, I'm going to go divided by, copy and paste, you're going to hit what is the second key and go down below the 3 and find the answer sign. And this will be my final answer, $12,951. And it looks to be here 35 cents. Now, if you use this formula, it looks like you may have gotten 32 cents, and that also would be acceptable.